Okay, class, very quickly we're going to do a little review on slope. Now, slope is rise over run. So, if we're given a graph, a little easy, we can go and count our rise. 1, 2, 3. Now, if I go up, that's positive. 3. Now, if I go to the right, which I am, that's positive also. Let's count 1, 2, 3, 4, 5, 6. So my rise over run, or my slope right here would be 3 to 6, 3 over 6. Now, look at number 4. If I'm going downwards, that's going to be negative. 1, 2, 3. So, negative 3. Then, 1, 2, 3, 4. Positive. So, I'm looking for rise over run. Now, there is another way to do that. y2 minus y1, x2 minus x1, or over x2 over x2 minus x1. But if we're given the graph, we can just look, count how many places we're moving, and find slope. Now, number 5 is different because what's my rise? Well, I'm not going up at all. It's 0. As soon as I see that it's 0 on top, I have no slope or 0 slope. How about this one, though? Well, I have a rise, but do I have a run? No. Now, 1, 2, 3, 4, 5, 6, 7 over 0 run. Can't divide by 0, and for this, we would call it undefined, which I ran out of room, sorry. Whoops. Undefined. So, what about if we have these types of problems? Well, we can use the formula y2 minus y1 over x2 minus x1. So for problem number 7, y2 minus y1, 9 minus 6, over x2, which is 6, minus x1, 3. And we get 3 over 3. These two right here, I'm not looking for a numerical answer. What I'm looking for is a positive or is it negative, 0 or undefined. You just tell me which one is it. Now, if you remember slope, dude, if we go uphill, let me erase these. That's puff, puff, positive, nice, negative, 0, that should be flat. Let me make a flat one. 0, fun. And then the curse word for math, which is undefined. So, look at number 1. Am I going uphill? Am I going puff, puff, positive? No, I'm actually going downhill, which is nice, negative. But right here, number 14, I'm not doing any of these. I have one that is undefined. Okay. Now we had this problem also. Could the set of ordered pairs describe the number of seconds since you left home and the number of meters you walked? Is this a function? Well, we can answer the first part, but let's look at the question. Is this a function? Well, there's a couple ways of doing this. I can get my x and my y, my domain and my range, and we can line them up. Now, I can look, do I have any domains that repeat? I do. 2 comes out twice. That means it needs to have the same range or same y. They don't. Since 2 equals 5 in one case and then 2 equals 8 in another, I could say this is not a function. If I was to graph this, let's count by 2's. So 2, 5, 3, 5 would be right next to it. 4, 6, say about there. But then I have 2, 8. It's right here. And then 6, 7. What happens? Well, if I connect them, guess what? It'll fail the vertical line test. But there's also another way. So this is saying that every 2 seconds, well, not every 2, but after 2 seconds, I'm at 5 meters. And then 3 seconds, I'm still at 5 meters, but when I get to 4 seconds, I'm on my 6 meter. But then it's saying, oh, travel back in time to 2 seconds ago. You traveled 8 meters? That doesn't make sense. That doesn't work. So no, these wouldn't work out. Now, let's say you had this instead. Let's say this was gone. And the next one was 6 seconds to 7 meters. Then yes, it would work. Because it makes sense. Because every second, I'm traveling further and further away from home. 2 seconds, I'm at 5. 3 seconds is 5. 4 seconds is 6. 6 seconds is 7. So it starts to make sense. Probably at 5 seconds, I may still be on my 6 meter. These are the types of problems that we're going to look at later. But there's not just one way to prove it. Someone could say, well, in order for this to work properly, it has to be a function. That's why they asked us also, is this a function? We could say, well, if I graph it as I plot my points, it should continue to go upwards and to the right. It can't, or should not, if they work properly, come back around like this. Because I'm traveling further away from home. I'm not going to come back home. It doesn't say anywhere that I'm coming back home. It's saying since I left home. And I'm traveling in what direction? Further away, like that. Okay? So as we continue with this unit, we're going to look more and more at these types of problems where we have to stop and think, remember how slope works, understand functions, and make sure, can we prove if it's a function or not? And understanding how functions work will help us to prove if certain numbers can be used, if they're being used properly, does it make sense or not.